Hey guys, we're going to do a little video lesson here on 3.1 and 3.2. Real quickly here on the screen you'll see that our agenda today is we're going to be collecting our problem set. We're also going to do a little bit of a warm-up in class, and we're going to take some notes, and hopefully we'll finish with the exit ticket, which is on the back of the warm-up. Alright, so if you're not in class, sorry, you missed us, but you can catch up here on YouTube. Don't be afraid to subscribe to my channel as well, so you can get all of our videos, and as I update them over the year, you'll be able to see when those updates come through. So a quick shout out to my YouTube channel. Alright, so let's first go ahead and look at our notes in our notes packet. It's got an orange cover to it this year, and when we look at it, that's our first page of our notes, 3.1 and 3.2. More importantly, we're going to be looking at how lines interact with each other in space, and when we look at that, that's going to help us to identify angle pair relationships, specifically when two parallel lines intersect a transversal or a third line. Okay? So zooming in here on our notes, let's go ahead and come up with a few definitions to start. The first term is parallel lines, which we've probably seen before and talked about. But parallel lines, their definition is two lines in a plane that never intersect, meaning that they never touch. Never touch. Okay? So when I look at my rectangular prism here, a lot like a tissue box, you can kind of visualize this as a giant tissue box here. Each of my corners of my tissue box have different letters, okay, associated to those points on its dimensions. So then if I go ahead and look at this picture and I wanted to highlight or outline two lines that are parallel, let's look at segment AB, and let's look at segment EF on the front of my box. If I would extend those two lines without bound, I would continue drawing AB and EF, and they would never intersect. So I can say that those two lines are parallel lines. Okay? Now, skew lines is a little bit different, but skew lines, okay, are lines that do not intersect, a lot like parallel lines. They do not intersect and are not on the same plane. Not on the same plane, meaning they're not on the same surface of my example here. So, for example, we could look at ray or segment BC, and segment BC would be skew with a line that's not on the surfaces that BC includes. Right? It's not on this surface or this surface, right? But it is included somewhere else. For example, like AE, right? AE, if I would extend AE forever, that line would be skew with the line BC. Skew. We also have some notation we probably want to denote here. Parallel, typically you'll see if two lines are parallel, they'll have two slashes like this, so we can say that AB, segment AB or line AB, is parallel to line EF. Same thing's true for skew. Skew doesn't really have a notation, so we're just going to say that they're skew. And then our last relationship here are perpendicular lines, which two lines that intersect and form a right angle. So if they intersect, they have to be on the same plane. And they also are going to touch and form a right angle. So let's say I'm trying to find perpendicular lines through point A. AE is one segment, and another segment that intersects with that would be AB. AB. So those two lines, as long as it's a rectangular prism, these two lines are going to form a right angle, and they intersect at one spot. So we could say that AB is perpendicular, upside down, capital T. That's my symbol for perpendicular. AB is perpendicular to AE. Okay? So we have parallel, perpendicular, and skew. Let's go ahead now and do some practice problems and see if we can identify these relationships using a different tissue box or rectangular prism. Go ahead and feel any time. If you feel like you're understanding the lesson and you get it, pause the video, try the example problems, and then speed me forward and see how you did. So when I look at example 1 here, WZ, I'm going to use my highlighter tool here in yellow. WZ is this line. XY is, WZ. WZ, that's this line in the front. and XY's in the back, they're on the same plane, they never intersect, so these would be examples of parallel lines. Let's erase here real quick. Now let's look at WZ, same line up top here, and QW. Since this is a rectangular prism, we know that this is at the intersection at W is going to form a right angle, so I would call these perpendicular. Lines. Cool. Erase again. And now let's look at SY, which is this line right here, and WX, this is right here. Both lines don't lie on the same plane, and they'll never intersect, so these would be considered skewed lines. Now parallel perpendicular can also be applied to planes as well. So here we want to know what's the relationship that plane WQR has with SYT. Now this is a little tough to visualize, but we're going to use two different highlighting colors here. Plane WQR. WQR is this front plane right here. That pieces that's in the front. So that front tab, and let's use green here for SYT. SYT, that's the plane in the back, right? And if this is a three-dimensional shape, right, that's the front of my tissue box and the back of my tissue box. And if you can visualize that, it's a little tough on a two-dimensional surface, but we can realize that both of these planes are going to be parallel to each other. Now let's go ahead and check out our last two planes here. RZS and WQR. Again, using my highlighter tool. RZS, that's this side of my tissue box. And QRS. QRS, that's the bottom. I'm looking at the points and I'm seeing which surface that they all lie on. And here, since we're looking at the bottom and the side, this is a rectangular prism, I can go ahead and state that that's going to be perpendicular. Those planes are perpendicular because they intersect on the line RS and they form a right angle. Perpendicular. Cool. So let's go ahead and just do some more practice here. They want to know in these examples, think of each segment on the diagram as part of a line. Which lines or planes appear to fit the description? So we're looking for lines, in number 6 here, line or lines that are parallel to AB. So if AB was in green here, and this is AB, lines that would be parallel are on the same plane but never intersect. So if I look at the top surface, DC, line DC would be parallel to AB. Also, if I look below on the bottom surface, right, I have HG, and I also have EF. All of these lines would be parallel to AB. Alright. Lines that are perpendicular to BF, well, that means I'm going to go ahead and look at BF here in orange. That's this line right here, BF. And if I'm going to be perpendicular, I have to intersect the line and I have to form a right angle. So that could be this guy, that could be this guy, that could be this guy, or it could be this guy. There's those 4 here for this one. The first one in the front is line AB. The other one on the top there on the side is BC. Down at the bottom I have EF or FE. Doesn't matter the order here for a line. And I also have FG. those are all the lines that I could possibly form perpendicular to the line BF. Now if I'm looking for skew, and we'll use a different color here, we did green, we did orange, let's do purple. Skew to the line CD, but they have to contain the point E, so point E has to be part of it. And this is CD, right here in the back. So if CD is right in the back there, and we need to contain the point E, we need to think of lines that are not on the same plane as CD, but will never intersect. So one of those options is obviously EF down here, that would work. Or I'm sorry, EH, and contains the point E and the point H. The only other one we could really see here is AE going here. The only reason we would include EF, because EF technically is parallel, and technically I could draw a plane through two parallel lines. So the other one would be AE. Here we want to name planes that are perpendicular to ABE. I'm going to use my highlighter tool now. I'm going to go ahead and erase this work for just a second. You can always go back and rewatch it in the video. Let's go ahead and in red here, let's highlight the plane ABE. That would be the front of my tissue box or rectangular prism. So that's this guy right here, in the front. And perpendicular means that they have to intersect and they have to form a right angle. And because this is a rectangular prism, we know that the four sides are obviously going to lead to the four adjacent sides that could be perpendicular. So we're looking at the side over here, we're looking at the top, we're looking at this side, and we're looking at the bottom. Those are my four perpendicular planes. So let's go ahead and name those four planes using letters that fall on those planes. So on plane 1 we have ADHE, so I'm going to use ADE or AED, or any order those letters works. I also have the plane on the top, which we can call ABC. The plane on the other side here, where my pen is, the gray side, and this could be BCG. And the bottom of my box, we could call it HGF. That's an A, Mr. Ausel. Jeez. HGF. There we go. So there are four planes that are perpendicular to ABE. And now we're looking for planes that are parallel to ABC. Parallel to ABC. So let's go ahead and highlight our surface here, ABC. That's the guy up top here. And if I'm parallel, I never touch. Two planes that never touch, and they're not on the same plane, obviously. So here, let's go ahead and look for, if this is up here, the only other side of a box that's not going to touch it is this side down here. So that would be plane EHG, or any three letters that lie on that surface. Okay? So that's the first part of our notes 3.1, when we're talking about how do lines kind of interact with each other in space. Now we're going to look at a specific case when we're looking at two lines that are parallel and a third line that creates angle relationships. So, real quickly here, we're looking at the next page of our notes. And there's special types of angle pair relationships that exist when two lines are parallel and a third line, we'll call it line T, intersects those parallel lines. More importantly, there's 8 angles that are formed. 8 angles are formed by those two parallel lines. And I'm going to use my yellow highlighter tool here just to show you where those angles are. We have one angle right here, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. So, let's first kind of look at the relationships of when those two lines are not parallel versus when they are parallel, and what that causes those angles to become. Okay? So, first, let's go ahead and define some things we've already talked about in previous classes. First thing is vertical angles. Vertical angles are keywords to help remember that they're kind of diagonal or they're across from each other. They have to fall in the same intersection, right? So if I'm standing here at this intersection, two angles that might be vertical are angles like 1 and angle 4, right? Angle 1 and angle 4 are considered vertical angles. And if we know that those angles are vertical, then they have to be parallel. If L and M are parallel, that's kind of irrelevant because vertical angles are always congruent. Always congruent. They do not need lines to be parallel for that angle relationship to be congruent. Okay? Then we also have adjacent supplementary, which is another way to say a linear pair. Linear pair. And just because angles are supplementary doesn't mean they have to be adjacent. But in this case, since they are adjacent, then we can call them a linear pair. Our keyword to remember is next to. So if two angles are next to each other, for example, like angle 1 and angle 2, maybe angle 1 and angle 3, those would both be examples of angle 1, angle 2, or maybe you're looking at angle 1 and angle 3. Those are both examples of linear pairs. And since those are linear pairs, then we know that they have to add to 180 degrees because they form a straight angle. So those are some relationships that we've already talked about. There's some new ones that we're going to add today for angle pair relationships, and they specifically deal with when we're looking at two lines that are parallel to each other and a third that intersects those two parallel lines. So the first one we're looking at here in our notes is corresponding, and the key word for corresponding is going to be same side skip. Same side skip is a great way to remember it. I've also used the phrase of a car or cars, okay, because these intersections of lines kind of form little mini cars where you have your driver, you have your passenger, and you have your two guys in the back seat, right? Passenger, passenger. And those four people in the car kind of make a little car here. There's my headlights. Mr. Ausel is not the best artist, but he's going to try. So here's my little car zooming by. I have my driver and I have my four passengers. And I'm going to explain that a little bit more here. But let's first look for corresponding angles in our example here. So let's assume that for corresponding angles, they're on the same side and they skip. Meaning if I'm standing at angle 1, if I stay on the same side of my transversal, meaning I stay on the left-hand side of the transversal, I skip this angle 3, and then I go down to angle 5, we can say that angle 1 and angle 5 are corresponding. Now if I went to the other side, and let's say I looked at angle number 4, angle 4 here in this space, I would go down the line, I'd skip 6, and I end up at 8. So we can say that angle 4 is corresponding to angle 8. Okay? Now the car example is a little bit different, but let's say I'm heading down the transversal highway, which is labeled with a T there. This is my road that I'm traveling down. I'm heading down the transversal highway. I got my little green car right here, and if I'm driving this direction, right, angle 1 is in the driver's seat. Now right behind him, tailgating him, is another car. We'll call him the purple car here. And in the purple car, there's also another driver. And who's the driver in the purple car? Well, that would be 5. And angle 1 and angle 5 are both the drivers, so they're corresponding in their location of the car. Does that make sense? So, use it or lose it. It's up to you. But I just want to give you guys multiple ways to kind of remember these angle relationships. 1 and 5, 3 would go with 7, 4 would go with 8, 6 would go with 2. And that should make sense. Now, if L and M, the two roads that form those cars, if L and M are parallel, then the special relationship occurs that these angles are congruent to each other. If parallel, then congruent. If parallel, then congruent. Okay? So let's look at consecutive interior, alternate interior, and alternate exterior now. Now these three angle relationships all kind of have to deal, these words, consecutive, alternate, interior, exterior, kind of give you an image of where you're lying on this picture above. So let's look at consecutive interior. When you hear the word consecutive, you should think on the same side of the transversal. The same side of the transversal. So they're on the same side of the transversal because they're consecutive. And they're interior, meaning that they are inside. So same side, inside. That's my little saying. Same side, inside. So when I look at this picture up here with L and M and T, same side of the transversal, T, so same side, like 5, and inside means 3 and 5 because they are inside the two other lines, not the transversal. They're inside L and they're inside M. So another relationship that you could have, obviously, if 5 and 3 are alternate interior, or I'm sorry, consecutive interior. The other pair that would also fall into that category are 4 and 6. Angle 4 and angle 6 are also consecutive interior. Now, if those lines are parallel, 3 and 5, 4 and 6 are going to be supplementary. So if the lines are parallel, then they are supplementary, meaning that they add up to 180 degrees, right? They're supplementary. Alternate interior, kind of like consecutive interior, but the word alternate doesn't mean same side, it means opposite sides, So consecutive, same side, alternate, opposite sides. So when I look at angle 3 is now going to be associated with opposite side of the transversal, inside the parallel lines, 3 and 6. So angle 3 would correspond with angle 6. Also, that would mean that angle 5 corresponds with angle 4. Because these are alternate interior, by definition, if the lines are parallel, then they are congruent. They are congruent. Alternate exterior is going to be the same thing as alternate interior. They're going to be congruent, but now they're going to be outside. Exterior means outside, and opposite sides of the transversal. So opposite sides, that would be 2 and something on the other side, and since it's outside the two green lines, 2 and 7 would be opposite and outside. So like angle 2 and angle 7. Okay? And again, if they're parallel, that means they're going to be congruent. Alright, so let's do a couple example problems, and I'm going to give you some space to kind of try some on your own. First, we're going to look at, let's look at A, B, and C, and then you can try D, E, and F on your own. A, B, and C. So, since 9 and 2 share a vertex and they're opposite of each other, these would be considered vertical. 6 and 5, here's 6, use a different color, here's 6, and here's 5. So 6 and 5, since they share this line, look where they intersect, the two lines they intersect, this is the line they share, that's my transversal. They are on opposite sides, they're on opposite, and they're outside K and L, they're outside the two other lines. Opposite and outside should tell you that they are going to be opposite, alternate, ALT, alternate, exterior. Alternate, exterior. What about 3 and 8? Let's look at 3 and 8. 3 is right here. 8 is right here. What line do they share? They share line K. That's my transversal. They are opposite sides, and they are also inside the two other lines that they don't share. So opposite and inside means that they're going to be alternate, interior. And I'm using abbreviations just to shorten it up a little bit. Alternate, interior. So use that same logic. See if you can go ahead and try to figure out D, E, and F. And I'm going to throw my answers up here. So pause and try them on your own and then see how you do. 2 and 7, they're going to be a linear pair. 12 and 5. 12's right here, 5's right here. Those would be corresponding. And 2 and 3. Those would be consecutive interior. Consecutive interior. Okay? Now, because of these special relationships, if we know that two lines are parallel, like L is parallel to M, then we know that there's special angle relationships. So when I look at angle 8 and I look at angle 4, 8's located right here, 4 is right here. Those are corresponding angles. They're in the exact same spot of the car. Also, it's angle 4, I skip 6, I go to 8 as I travel down that line. So because they're corresponding and they're parallel lines, I know that they have to be congruent angles. Angle 2 and angle 3, those are vertical angles, so that means they're going to be congruent always. 6 and 5 are adjacent to each other. Sorry about that, a few afternoon announcements here at Stonebridge. So, 6 and 5, they're going to form a linear pair. So if 6 is 120, that means 7 is going to be the supplement, meaning I can take away 120 from 180, and that's going to give me an angle of 60 degrees for angle 5. If angle 5, here in this example, let's use a different color. Let's use purple there. If that's angle 5 is 80, and angle 4 is the alternate interior, that means they're going to be congruent to each other when they have parallel lines that they share. Angle 1, let's use blue here. Angle 1 is 75, and angle 6, their relationship is a little bit different. Opposite sides, not on the same side. So we're going to have to use what we know about corresponding angles. Angle 1, skip 3, go to 5. So angle 5 is going to be 75 in this example. And angle 5 and angle 6 are a linear pair, so when I take away 75 from 180 and I find its supplement, I end up with 105 degrees. So that's a quick example and video for notes in 3.1 and 3.2. Go ahead and try the problems in your practice packet, and I'll see you next class. Have a great day.